James Webb Space Telescope just got hit by a micrometeoroid. Well, it's not uncommon to hear from NASA about potential triggers in space, where an asteroid is seen to have been attracted by the Earth, and if the universe doesn't want us to live any longer, they might hit the Earth and maybe, cause another great collision, who knows. But this time again, we're saved, thankfully, and if you don't know from what, keep your eyes on the video, cause things are gonna get interesting. Hey guys, and welcome back to the channel. We hope that you've been well and caught up in all of our latest updates. We're back with some big news about a micrometeoroid that hit the James Webb telescope. To find out what happened next, again, you gotta keep watching to the end, so yeah, stick around, and let's get into it. The dust-sized micrometeoroid's destruction is clearly visible in the observatory's data, but this is not anticipated to have a significant impact on the mission's overall quality. James Webb was introduced in December to replace the groundbreaking but now aging Hubble Space Telescope. On July 12th, astrophysicists are expected to publish their initial views of the cosmos. According to the U.S. space agency NASA, the recent events won't make these images any less stunning. Are the impacts serious? Given the impact of mildly misaligning the telescope, it seems not. In a Twitter post, Thomas Zurbuchen, the current associate administrator at NASA's Science Mission Directorate, stated that Webb recently sustained an influence around one primary mirror segment. The team discovered after preliminary evaluations that the space probe is still operating at a rate that enables all operational requirements. The primary mirror section of the newly built James Webb telescope was struck by a micrometeoroid between May 23rd and May 25th. According to NASA, the event was significant enough to pick up a barely perceptible effect in the information, but didn't really have an impact on the telescope's operation. The James Webb team conducted a preliminary evaluation and discovered that it continues to deliver at a higher level compared to all operational requirements for space missions, which is what NASA said in a statement. With Webb's mirrors revealed to space, the team anticipated that sporadic micrometeoroid effects would gradually reduce telescope performance and efficiency, according to Lee Feinberg, Webb's optical observatory element manager at NASA Goddard. 4 smaller, quantifiable micrometeoroid incidents that were in line with the expectation have occurred since release, and the most recent one is greater than any of their most recent degeneration predictions, and what they have assumed. He continued by saying that they would use the flight information to update their analysis of performance placed above a specific time, and to develop operational strategies in order to ensure that they could maximize Webb's imaging performance for several years to come. They emphasized that in order to ensure that the telescope was strong enough, engineers used simulations and tested impacts on mirror samples. In one good example of a case similar to this, NASA disclosed that the telescope's flying teams had the skills necessary to execute evasive maneuvers that would have allowed the optics to back away from known meteor rains. Because the micrometeoroid that struck the telescope most recently was larger than anything that could have been tested on Earth, it was classified as an inevitable chance event. The telescope can, however, change the positions of its mirrors to lessen the effects of destructive consequences. In order to compensate for the destruction of the impacted section, they've already made a number of adjustments. In order to find ways to mitigate the effects of prospective hits of this magnitude, it also assembled a team of engineers. Hubble and James Webb comparison. According to the analysis, one of the 18 beryllium gold slabs that helped compensate Webb's 6.5 meter wide primary reflective surface, recognized as mirror segment C3, was apparently struck. According to NASA, the contact left a bulge in the segment, according to Reuters. Because of how quickly things move through our space, even those minute particles that collide with another entity can produce a significant amount of energy, with this most recent incident being the most substantial. Webb has now been struck 5 times. The reflectors on Webb are not protected by the same type of tubular baffle found on other space probes like Hubble because of its open concept. Instead, the reflectors are concealed by a massive sun shield, which enables them to sustain the steady, chilly temperatures required for infrared light detection. Contingencies were built into the material selection and the component building in various telescope operation methods in order to account for the potential for micrometeoroid impacts. As for the meteor strike, here's what NASA said. The production team at NASA's Goddard Space Flight Center in Greenbelt, Maryland, according to Technical Deputy Project Leader Paul Geithner, always felt sure that Webb would have to withstand the harsh ultraviolet light, as well as charged particles out from sun, cosmic rays from unusual sources in the cosmos, and occasionally occurring micrometeoroid impacts within our solar system. He went on to say that he constructed Webb with performance margins in mind, including electro-optic, electrical, thermal, and mechanical strategies to guarantee that it could carry out its ambitious scientific mission even after spending a long time in space. Engineers can eliminate some of them, try to introduce distortion by moving the position of the problematic mirror segment, but not all of it. For the purpose of showcasing its capabilities, Webb is currently collecting observations from the entire universe. The world will see these images from astronomers in the upcoming month. The scientists hope to use Webb in the big scheme of things to try and spot the very first stars and celestial bodies that lit up the entire universe more than 13.5 billion years ago. They'll also focus the large eye of the telephoto lens on the atmospheres of far-off planets to determine whether or not those worlds might be able to support life. Will the micrometeoroid impact harm Webb? According to a recent update from NASA, even though the consequence was barely perceptible, the telescope was unaffected because it's still operating above and beyond all mission objectives. Webb's mirror was designed to withstand the bombardment because scientists were aware of the frequent micrometeoroid impacts. The reflective segment's effectiveness is still far above expectations because these occurrences were anticipated during construction and ground testing. The primary mirror was subjected to simulations and test execution impacts during the telescope's infrastructure in order to, get it ready for orbit at L2. Webb is fully installed at the second Lagrange point, which NASA claims is an atmosphere for micrometeoroids because the area is characterized by extremely fast-moving dust-sized grains. The highly anticipated launch of Webb. On Christmas Day of 2021, which is fairly recently actually, the $10 billion Webb spacecraft was launched. It's been hovering at the L2 point, which is 1 million miles or 1.6 million kilometers from Earth as of February. On the July of 12th, the 12th of July, the first light images from it are expected to be released. They're anticipated to be a stunning display of what the most sophisticated space observation deck in history is capable of. According to NASA, analysis as well as measurements are still being conducted, but it doesn't appear that the science scheme that will come after or the initial images will be significantly impacted. And that's because developers were able to correct for the dented segment by moving it 18 mirrors. Has this type of thing happened before? The strike on Webb isn't the first one. According to Lee Feinberg, manager of the Webb Photonic Telescope aspect at NASA Goddard, since launch we had 4 smaller quantifiable micrometeoroid strikes that were comparable, and this one, extra recently, that's bigger than our deterioration predictions had assumed. According to NASA, mission team members can reduce the impact of effects in the future by making adjustments in the mirror segments. Additionally, they can employ defensive actions that purposefully direct the optical components away from the forecasted meteor showers. The most recent impact was an unavoidable chance affair, according to NASA, rather than the result of a meteor shower. Notably, the organization has now assembled a group of engineers to look for ways to lessen the effects of additional micrometeoroids of the same size. And we've reached the end of our video today. So, if you enjoyed the video, then smack that like button, subscribe to the channel, and turn on notifications to never miss an update. Leave your suggestions in the comment section down below. Thanks for tuning in, and I'll see you next time.